In meinen Ausführungen zeige ich, welche Rolle Erdgas in Zukunft im Wärmemarkt spielen wird. Dabei kann Erdgas in Zukunft alle Wärmeanforderungen im Zusammenhang mit anderen Effizienzmaßnahmen erfüllen und auch in Zukunft im Zusammenhang mit Power-to-Gas und Biogas für die Versorgungssicherheit eine wesentliche Rolle spielen.
I'm representing the ASUE, which is a community of public utilities, energy supplying companies which have come together to go into energy efficiency on all levels. This includes practical application in heating basement, but also in many other areas. For example, in gas turbines, where we are quite well known. The hub of our association are working parties of utilities, of contractors, of manufacturers coming together, asking about fostering of innovation and efficiency to get to practical, feasible solutions instead of indulging in theoretical approaches. In the following, let me enlighten on a few data and facts, which have also been mentioned by the previous speaker. Climate protection with the respective plan as a central element and impulses of our government. Let me present it here with the consequences for the heat market. The Building Energy Act, with its important points, asking in how far it plays a role regarding gas. Then the subsidization of the existing stock of buildings. And of course, I want to give practical clues for that matter. The living quarter of the future, quarter-based solutions is quite a present subject matters as one of the catchwords for future energy supply. Let's also see what current efficient uses are from our point of view. And there's the question, is there no alternative to gas? Question mark. Are we on a lock-in path, a path which is not robust enough, or is it part and parcel of climate protection? And is it based on a strategy for climate protection? Well, and at the end, of course, I'll give you my summary, and I hope I abide by my timeline. Here, the facts and figures I want to mention to you. Maybe you cannot read everything, but you can see such charts quite oftentimes. 44% of primary energy in Germany is consumed in households or in the heating market in general. 38% of the entire energy are consumed in private homes and for hot water preparation. Those are 500 terawatt hours, as much as we use in the form of electrical energy. That's how much we need for the preparation of hot water and for heating rooms. On the other hand, 64% of the houses in the stock need to be modernized in terms of energy efficiency. Hence, we have not yet even reached half of our goal in terms of state-of-the-art. 30% of all heat generators built into houses are only state-of-the-art. 70% should be substituted overnight, actually. Sometimes 25 or 30-year-old heatings are installed in a house as energy carriers. We have more than 1.3 million electrical direct heaters in Germany. Quite an inclusive thing, because this is terribly expensive, even if it's night storage heater, which is even subsidized. But in terms of energy efficiency, electrical direct heating is not state-of-the-art, for sure. In terms of affordable actions, things you could do with little money, substituting heatings, new heat pumps, maybe better ventilation technology. These are affordable actions we could undertake, and 200 terawatt hours, hence 2/5, nearly half of our energy could be saved relatively quickly and cheaply, even by means of subsidization. And of course, we cannot do without gas against this backdrop, at least not in an affordable way. To see how throughout the years the stock of buildings in Germany has developed in energy-specific heat requirement, you see that by the turn of the century, about 120 years ago, the houses were saving energy quite well because we used to have coal and we need to get it from the basement. Walls were thicker, we had double windows. And then after the war, in the fast redevelopment phase, this was forgotten as an energy-based action. And the worst houses are from 1973, during the first oil crisis, when the awareness developed that we have to save energy because it's too expensive. And the high price of one of the big drivers of energy saving characterized this development and then went downward. In 1975, there was the first heat protection ordinance, followed by a heating insulation ordinance, then the EU directive on buildings, and the first energy-saving regulation in 2009. And the legal provisions are to be considered drivers of improvement in energy efficiency. But we have not yet reached our goal in that regard. I mean, all these are houses which are still in existing and consuming heat. So as of those years of construction, people started saving energy to a meaningful extent. You see the scenarios here: oil crisis, climate debate, then it goes further down. And now there's the scenario of the energy transition. The reference house within the framework of the NF 2016 has reached about 68 kilowatt hours per square meter and year on this scale to the left. And with further progress, the next energy standard we have just talked about as of 2021 possibly will get to 40 kilowatt hours. And in the long run, if we get energy and climate neutral stock of buildings, we may reach 20 kWh per square meter a year. The Climate Protection Plan has brought a whole series of topics with it. It was also taken to Marrakesh as the German model, showing we are on the right track. We have introduced binding actions, and if the politicians say binding, committing, and they mean it, as it were. And there are quite a few essential topics. I don't want to mention full detail, but it's about transformation of society. A question whether all will be able to jump on the bandwagon. For example, whether we'll keep all our jobs in industry. This is not mentioned, although it's interesting in the long run. Here are a few topics which are interesting for my further presentation. Power consumption, in order to open up the heat market pursuant to the Climate Protection Plan, shall be higher by 250 terawatt hours. That's the heat requirement of 500 multiplied by the degree of efficiency of a heat pump. And well, this will take us to 200, 250 terawatt hours above the power consumption we have now. That may sound logical for a start, but the Climate Protection Plan also says that we should substitute natural gas by CO2 neutral gases, which points to gas, and we cannot do without it for sure. We'll come back to this in a minute. KWK, as an important development action on climate protection, has also been mentioned, and geodetic, biothermally based power supply is mentioned. And, well, this is a component part for practical implication and implementation, maybe. I've also mentioned heat pumps because we don't want to delimitate technologies or exclude technologies. But according to expectations, if until 2030 we build in heat pumps, we'll also have higher power demand, which at the moment is essentially satisfied by lignite and hard coal. And this would certainly lead to increased levels of CO2 emissions. The question is whether we want it. That's a decision to be taken by the government. But we show this in the full context and say, well, if you want A, then we also need B. At the top, renewable energy is mentioned, which is growing to the tune of about 4,000 megawatt hours on a yearly basis. This is also mentioned in the pertinent plan. And below, there's gas as a swing supplier, waiting for more use. It's not used that much at the moment because as long as we don't have, as we don't take out coal-based power plants from the stock, gas, also because of its price function, will mainly fill the gap. That is only about power generation in the first place. Then hard coal and society in middle load, and then below in base load. The lowest field, the blue one, those are the nuclear power plants which will be switched off by 2022. The last one will be put out of operation by then. Then lignite and hard coal will come in base load, running for thousands of hours per year. That will be a plus of CO2 emission by 70 million. And if we add electrical consumers on top of that, this will lead to more electrical demand for generation. Hence, we'll need a lignite and hard coal-based power supply, and will very clearly miss our climate-oriented goals, to put it bluntly. We have already mentioned the energy-saving ordinance, the renewable energy heat law, which will go into the GEG, the Building Energy Act. In the new Building Energy Act, nothing much more was done than within the structural framework set by the NF and EWärmeki, the former Energy Act. A few minor things have been included, like more stringent rules for the existing stock of building, especially as of 2019, especially for public offices, hospitals, prisons maybe. And there the federal government said when the draft was presented to the cabinet, well, that's not really what we want, it will be too expensive. And, well, show that holds for all buildings as of 2021, even for residential buildings. Is it not too expensive for private consumers, but only for public authorities? Well, this is something the government will have to answer, maybe even before the election. Here I highlighted a few more points. That's the near zero emissions building house, NZEB. That's a European denomination for it as of 2021. For all new buildings, this will become binding. And of course, these are technical challenges which need to be realized in practical terms. You cannot only say that has to be, but you also know how to realize it. Well, then the cogeneration of heat and power need to be seen, German abbreviation KWK, which would mean a 50% application with 50% renewable energy. And still another important new point are regulations regarding quota-based solutions. At least name has already been created, and so maybe this is a definition for the future. Now, what are the chances of natural gas? Because the title of my talk is Natural Gas in the Future. Well, as of 2021, natural gas, together with other efficient technologies like ventilation, electronic control, freshwater stations, will contribute to a primary energy demand, fulfilling the conditions of an efficient house as of 2021. Biomethane, together with cogeneration, can offer economic intelligent solutions, even with zero emissions, above the biogas share. It's also a good condition for the demands regarding renewable energy and its use, not only investing a lot of money, but also considering incentivization. Quarterly-based solutions are even better because energy storage or large-scale use of solar thermal energy only makes sense in larger units, like on quarterly basis or on the basis of suburbs. Something else is new, namely the federal states can introduce a constraint for connections to district heating. Well, no one loves monopolies, but if we want to have highly efficient solutions, then we also need to consider technologies which function better. If you bring together 100 or 300 houses, then of course you need to offer the pertinent legal framework for that matter. So we sometimes even have to swallow such bitter pills, as it were. On a more practical note, we have to ask, what can we do? Well, there's a house of 1928 when, given the increasing wealth in Germany, houses became less efficient. As we'll see in a minute, there's an energy demand of 320 kilowatt hours per square meter in G, and this house, which is quite typical. And based on that, we want to do a KfW 55 house, the highest degree of subsidization. And we have considered fuel cells, top gas condensing boiler, hydraulic balancing. We also considered roof insulation, new ceiling in the basement, heat insulating protective glazing, improved facades. Of course, we could have established the sequence differently, but it gives a rough impression, showing that according to the calculation with a hot node system, the standard for energy built-in calculation, of 320 kilowatt hours to be brought down to 38 kilowatt hours, which is something where we can say this is possible. I didn't add an amount to it, but let's say it may amount to 1,200 euro per square meter built-up area, which may amount to 160 or 180,000 euro in an entire building. But these are the costs we have to expect. But we can only make it considering that we get from this high amount to 150 by the following trick, namely the building in of a new heating, hydraulic compensation, additional solar thermal energy for preparation of drinking water in summer, but also by the fuel cell, because the fuel cell produces power in a highly efficient way and contributes to saving. And according to the current calculation provisions, we get a nice feed in credit. So these are quite interesting options, and we hope that these things become cheaper. Fuel cells which still try to reach the market, considering that it makes sense to calculate it and that it makes sense to use fuel cells because it contributes efficiency gains. Fuel cells could also be spread more. And at the end of the day, it says KfW 55, which means incentivization for the fuel cell and for the entire action. So in sum total, this may add up to 45,000 euro, and then the 160,000 euro for complete modernization don't hurt that much anymore. And if you can save 15,000 euro per year in heating costs, then the rehabilitation of a building could really be a gain and pay in the long run, for sure. Apart from the fact that the modernization of a building is also an action in terms of goodwill, because we are all called upon to contribute to climate protection. Regarding this action, we also considered electric heat pumps, or BHKW, listed here. I want to move through quickly because my time is almost up. BHKW in terms of economic efficiency, because it generates power itself and gets the credit for it, is also lower in investment because there's also subsidization going hand in glove with it, like for the fuel cell. And, well, in terms of annual capital and operation costs, this means that economic efficiency is better in this kind of cogeneration than for an electrical heat pump. The position in terms of primary energy is worse, unfortunately, because an electrical heat pump is in the lead with very good primary energy factor on power in building heat. But on the other hand, the CO2 emissions shall also be counted in, which contributes a major difference because with a gas-operated cogeneration plant, you make an essential contribution to climate protection. Now, what about the future trends on the market? Well, we assume that will have better protection of buildings in terms of insulation, double or triple glazing. Efficiency-based actions will spread more, ventilation, panel heating, electronic optimization of the heating plants. Very big issue here. Control demand. As mentioned here, time and again, it would carry along a mobile, and the device detects whether you're in the house or not, or whether the heating needs to be taken up or down. That's an option which may sound like playing, but maybe it's something we did taken granted for in 3 years' time. Well, PV stations will replace biothermal energy to a major extent. And while, of course, mostly you get the best degree of efficiency if in summer everyone is off and there's no consumption of biothermal energy. And, of course, there will always be competition of such alternatives to gas, although we are convinced of the efficiency of gas technology. Of course, heat protection is still quite expensive, and there are other more affordable efficiency-based actions like large-scale ventilation and panel heating. And, well, of course, gas heat pumps will make their ways too. Structural measures, of course, are the best leverage to make further progress. And, well, I guess that after the next election, there will be another tax burden on gas in order to relax the EU reallocation portfolio, which has already been announced. And then, of course, there will also be a different price system for gas. because availability need to be appreciated differently than regarding electric power from renewable energy. This takes me to the focus to gas application technology. Cogeneration will further be subsidized and expanded. And while in quarters and suburbs, this can be integrated very well with the use of renewable energy. Fuel cells will become cheaper, and due to its excellent electrical efficiency, they will make their way. The gas motor heat pump in larger residential areas in line with geothermal energy or recycling of waste air. Then cogeneration, gas heat pumps, hybrids in heating systems, manual use, electrical operation in combination with a gas boiler just in case. And while system-based solutions will also make their ways more and more. A low-energy house has a small heating plant, which may later also be integrated in a recirculation air unit due to lower heat requirements, maybe. Well, some of the examples I have mentioned for demonstration's sake, well, the gas motor heat pump starting around 40 kW up to 100 kW, which is nothing for one family house, but for larger buildings. And by means of sound emission, this can also be used in industry, not only in private buildings, but of course we also need cooling and heat throughout the year with the right kind of distribution. And due to the fact that a gas heat pump, gas motor heat pump, is considered a cogeneration plant, you get a primary energy factor of 0.6, which I've applied here, with a better index and integrated ventilation. Then this takes you from 90 or 100 kilowatt hours to 30, and thus you reach the 55 threshold, because the question was how to get there. This is one option for it. Of course, you could say I won't evaluate it as such a plant, but as a heat pump, and then this takes you below this value of less than 30 kilowatt hours without any other efficiency-based actions. We're now working on a study to couple both effects, because a gas motor heat pump is not only a cogeneration plant in terms of definition, but also a heat pump, and thus you could reach high efficiency gains quickly. To show different future trends, well, since we are not yet efficient enough in power storage apart from small batteries and the like, well, sector coupling will also be an issue, especially represented by the electrolytic production of hydrogen from power. Power free of charge, power too much, no power. There will always be a market for power, but we need to store it, and we need to calculate what it will cost in the future. And there, the power-to-gas plants are one of the options we already have. All the other things we do not yet even have on paper, which we need to tell our electric specialists who keep saying the world will become electric. But the storage facilities they need do not yet exist. This, in line with a cogeneration plant, can be calculated, and you may say that you lose about 70–80%, or maybe you lose 20% in the production of electrolytic transition of power to hydrogen. And the cogeneration plant produces power with a degree of efficiency of 90–100% because the heat is not lost because it goes into the building. Then you get a degree of efficiency between 65–80%, which is as good as a pump-based power plant. So you may ask, how come that politics has not yet discovered this trend? Biogas can be used for more efficiency. We use it to the tune of 1% in the grid at the moment. In the long run, maybe 10% of the entire volume, 10 billion cubic meters, biogas, considering all environmental aspects, can be produced, and even in a fuel cell. Because the fuel cell can run the entire year, and the biogas plant can also run the entire year because it's a generator of the baseload. And this also takes us to a degree of efficiency of 85% with zero emission, and then biogas might get even a little bit more expensive. Now let me guide you through a vision indicating the main problems. To the right-hand side, you see the renewable energy illustrated in various relations, showing the peak represented by photovoltaics on the flat triangle represented by wind. Of course, I could have produced curves, but it would have taken longer. To the left-hand side, the heating requirements and the power requirements, which is there, and this takes us to a safe and reliable supply. From the right hand to the left hand, you can contribute as much as storage allows in technical terms. So I just try to illustrate how much it is, but this depends on the next technological developments. That's a core question. You need that much fossil energy on the side of safe supply on the left, which you won't get from the right to the left. And in a peak situation, which you may represent by an affordable, highly efficient option, which certainly may be gas in the future, that's the last recourse. But since this is still limited in terms of storage, then in the long run, you will have a very high contribution margin with fossil means or by gas. And well, of course, we also have to consider climate protection. Of course, there will also be heat storage, considering the power demand. Then to the top right-hand corner, you see power to heat. The biggest peaks are contributed by power to heat, the cheapest option, which you use if there's too much power on the grid. Then you rather use relatively cheap options like gas. And then at the bottom, you also see the heat storage, which you can use for a few days, not throughout the year. Then let's move on and say, well, power to gas will one of the major power factors in cases where no other power demand needs to be covered. And power to gas will also be part of the gas market in the future, also replacing it to a certain extent. And if you use gas as a fossil source of energy, then you can also consider biogas and power heat cogeneration, because in the long run, each gas burner should also generate power. Well, of course, this is also a matter of cost, but in order to achieve energy gains, we also need to invest money. Power to gas well, also need to be seen in line with power generation. And if you move on by one more step, there will also be power peaks which will be covered by biothermal means in combination with power to gas or with biogas. This takes me to an energy model which is not that simple. You cannot say, well, there's only power, only gas, only this and that, but there's a portfolio composed of various options, composed of the economic situation, availability, and the costing, but also storability and safe supply. That's all quite logical. You just need to study it in detail. That means that we'll also have a gas portfolio in the future. It is only reduced to the heat market, and we talk about 350 terawatt hours, but this will be replaced by biomethane and power to gas to an increasing extent, given more efficiency in the building on a declining market. And let's assume that we'll go from 350 to 280 terawatt hours on the heat market, operated with gas, but 20% will be contributed by power to gas and biogas. That will lead to new cost functions. The value of gases will no longer be paid in kilowatt hours, but maybe more in terms of availability. And that will also reach small consumers, saying if you need power amounting to 12 kW, then you can consider whether you want to produce it by electrical means, or then you need to put it in the basement. And, well, now what about the quarter of the future? What will it look like? Let's say at the fringes of Frankfurt, to show that we need everything. We have a gigantic energy demand, we have a mixed substance of buildings, and thus we need PV, solar thermal energy, heat pumps, electrically fed from a cogeneration plant. Thus, the heat pump gets lower initial flow heat. We have heat storage at the fringes of the city, which need to be charged. We have a power to gas station accepting excessive power, mixing it to gas or producing hydrogen. And, well, hydrogen is a very future-oriented development, also regarding the bacteriological production of CO2 through a biogas station, through anaerobic utilization towards CH4. Well, we have all these elements, and in order to have reliable supply in a residential area with a maximum of environmental protection, we need as many pillars as possible, and natural gas will certainly play an important role in that regard. Now my conclusion. In new buildings, we'll have 70% less heat demand. In the stock of buildings, the 25% will certainly be reached. That's the amount which is feasible in affordable terms. Everything going beyond it costs real money. Gas is considered the propulsion energy, and independent of the availability of renewable power, this can be operated. The value contribution of gas will be measured with a yardstick of reliable supply, and of course the price pattern will change accordingly. Then biomethane and power to gas will play a growing role, amounting to 15 up to 25% entire gas volume. The storability of natural gas is an important success factor. In a peak situation of power production, natural gas will play an important role, even gas in general, because it will not only come from the earth, and it will prove to be the cheapest avoidance option. Well, this is the fields we are working on behalf of ASUE, a very practical and interesting field where you can make meaningful contributions as engineers.
Interessantes und praktisches Umsetzungsfeld, in dem man sich als Ingenieur so richtig austoben kann.